Okay, so today we're talking more so about solving for angles today, as in the past we were discussing how to solve for sides. So maybe we wanted to solve for a missing side if given an angle, but here they're giving us the sides, but not the angle. So a little bit different here, still working with SOHCAHTOA, sine, cosine, tangent, still having to identify here is the angle, here is my opposite, here is my hypotenuse, here's my adjacent. Identifying what they're giving me, an opposite and a hypotenuse, and recognizing, okay, I'm going to use sine. And sine of angle K is going to be equal to my opposite over adjacent. Now, something a little different here. In order to get in algebra, if you had 3x is equal to 9, you divide by 3, divide by 3x equal to 3. So if we want to get k by ourselves, yeah, we want to divide by sine. But if you recognize in a calculator, we're going to do that. 11 divided by 39 divided by sine, there's an error here because something needs to be put in to this parentheses, and what is it that we're going to put? So that doesn't technically work. Now, one thing you could know is that sine can also be written as, or dividing 1 over sine can also be written as sine to the negative 1. This is an exponential rule. Basically, x to the negative 2 is written as 1 over x squared. It's an inverse. So what you're doing is you're multiplying by an inverse. So what you'll do is, on a calculator, make sure again that you're in degree mode and not radian. That'll change some of your answers. And what we're going to do is we're going to do second sine here. And you see above that you have sine negative 1. So that's going to give us second sine. That's our sine negative 1 there. So what we'll do is second sine, and then we'll put in that 11 divided by 39, and it'll give us a result of our angle, 16.38. And that's what angle K is equal to, 16.38. And if you like or need to solve for this other angle here, all you would do is just, let's call it theta. You would just subtract that from 90, and that'll give you the result of your other angle here. Now let's just look at a different case, one in which, now again, I myself am going to be writing this down each time. This way it keeps my information organized. Here's the angle they're talking about. That's very important. We'll call it theta. Recognize this is an adjacent. This is a hypotenuse. Remember, it can get mixed up as this being adjacent, but identifying this as a hypotenuse because it's opposite the right angle is important. These are both adjacent sides. They're both making up or part of angle R, but this distinguishes itself differently because it's a hypotenuse, because it is in fact opposite the right angle. Now if I have an AH, I'm going to be using a cosine of angle R is equal to A over 39. That's my adjacent over hypotenuse. Now remember, we're dividing by cosine, but remember, in order to do that, we need to do cosine negative 1 of 8 divided by 39. We're going to multiply by its inverse. And again, what you do there is second, our cosine up here is our cosine negative 1, and then we're doing 8 divided by 39, and we get a result of angle R being 78.16. Going forward, so we've done a sine, we've done a cosine, probably best if we take a look at a tangent as well. So I did set that up for you here. Here's your angle C. Here's your hypotenuse. That's not what they're giving us. They're giving us an opposite and an adjacent to C. That's our tan. I'll just go straight away and just say, I know I'm finding an angle, so tan negative 1, I'm just going to kind of skip a step and get right to my tan negative 1 of my opposite over adjacent of my 16 over 7. Oh, that's weird. Just make it look nice. Actually, let's change this to here, right? 16 over 7, and make our second tan negative 1, 16 divided by 7. and give us a result here of 66.37. So remember, dividing a sine is the same as multiplying, a sine, cosine, or tangent is the same as multiplying by its inverse. Its inverse. So this is what you'll be using to solve for angles. Don't forget, hard work makes math easy. Hard work makes math easy.